Yo, what's up, guys? Thank you for tuning in. I'm going to be reacting to Is Crab the Final Form by Lindsay Nicole. So, she's going to talk about, apparently the idea is a lot of animals. I don't know which types of animals, because, probably only other crab-like creatures that could turn into a crab. But apparently, over millions of years, lots of crustaceans, I guess, when given the chance, will turn into a crab, and I guess that's the theory. I don't know. Let's watch the video. Let's find out.
In the last few years, you might have seen any one of these memes about things evolving into crabs. That crab is the ideal form, that eventually everything will become crab. These refer to a real phenomenon called carcinization, which is, in the simplest words possible, the process of evolving a crab form. This has happened so many times, scientists had to create a word for it. Before you get all excited about the thought of crab people millions of years into the future, I must stop you right there. Like I said in my skit I uploaded a few weeks ago, in order to undergo carcinization, you have to be a crustacean. Can I do it? No, you're
That's what I'm talking about. Like, it can't possibly be every animal. It's just crustaceans. Like, what the hell?
Croatian. You have to be a crustacean.
Don't let that be like a bad like diminish the idea. There are so many animals or insects really out there that are technically crustaceans. So anything could really just turn into a crab, like out of nowhere.
Station. Nevertheless, be prepared for this video to inform you and potentially enrage you. If you're a returning viewer, you know we typically start with the general information to get it out of the way. So you might be thinking that I'll probably start by defining what a crab is. That's a good place to start. But listen, it is much more complicated than that. Defining crab is complete pandemonium. Here's why. When you think of a crab, your brain probably goes to a flat, rotund creature with little eye stalks and big claws. Well, on one hand, scientifically, not all creatures that fall into that category are true crab. And on the other hand, informally, we use the term crab to describe creatures that look nothing like that. In the words of biologist Gerard Schultz, sometimes a crab is whatever we perceive as a crab. No offense, but that is unacceptable for our discussion today. Guess how many research papers I went through of biologists just pondering what actually is a crab? It was ridiculous. Crabs are way too complicated. So I decided we're gonna visually organize this chaos with a diagram. I don't know what kind of diagram this is. I know it's not a Venn diagram because the circles are completely inside of each other. You know what the fuck is going on. I know that what I made is correct. So the outermost circle is things we call crabs. Inside of that, we have things we call crabs that also look like crabs. And inside of that, we have things we call crabs that also look like crabs that are also true crabs. Let's start with animals that only fit in the outside circle. Things we call crabs but do not even look like crabs. There's really no way to define this
See, the way she's talking, like the information is just coming at me so fast. Not even like I have to check if I have the speed on normal speed. I think I have it on normal speed, and that's just crazy that she's talking so fast. I can't understand what she's saying, man.
Category. It's just different animals that people came across and went crab. A few examples are hermit crabs, pubic lice, the last kind of crab you ever want to come across, and horseshoe crabs. This is clearly not a crab, yet we call it a crab. Why? All right, the next two are both categories that look like crabs. Okay, before we define the next two,
welcome to Is That an Actual Crab?
We have the blue crab, the porcelain crab, the king crab, the Japanese spider crab.
There's a lot of weird looking crabs going on over here.
Silence, Brad.
And the Dungeness crab. The Dungeness crab. At first glance, these all look like true crabs, but they are in fact not. Let's start by identifying the true crabs.
You know why I don't like true crabs? Because they got all these crazy looks, man. The long legs, big arms. True crabs are just tiny little crabs, I think. Man.
It's the smallest circle. This is the Dungeness crab, the Japanese spider crab, which can get to like 12 feet long. They're fucking huge. And blue crab. What do these three crabs have in common? Well, they definitely look like crabs, and they all belong to the same taxonomic group called Brachyura. Whenever we talk about taxonomic groups, we're talking about things that are related to each other through a common ancestor. These groups can be as big as phyla that I've shown you a diagram of. Each of these generally has a common ancestor that was alive like 500 million years ago. So these are really generic big groups. Or the groups can be as small as the big cat genus Panthera, whose common ancestor was alive like 6 to 10 million years ago. It depends on how generic or specific the group you're talking about is. And in this case, with Brachyura, all of its members have a common ancestor that was alive sometime in the early Jurassic period, nearly 200 million years ago. This was the beginning of the true crab lineage, the flat and rotund shape. And so, True crabs are defined by blood. They have their own little familial club. And throughout time, other crustaceans outside of Brachyura have wanted in on that body form. They evolved over millions of years and achieved this ideal shape, but are still not invited to the club. This is where the bulk of our carcinization talk exists. In our last circle to visualize, the in-between look like crab but not true crab, with examples like the porcelain crab and the king crab, which with a name like that you'd expect to be a true fucking crab.
Wait, what? Those are what? Yo.
Talk exists. In our last
How are those true crabs? How is the Japanese big ass crab an actual true crab? The only one that looks like an actual true crab is like the dungeon and the blue crab, bro. What the hell? Like only these two look like actual normal crabs. This one does not look like an actual normal crab, but this is a little too lanky to be an actual normal crab, bro. The hell?
circle to visualize the in-between look like crab but not true crab, with examples like the porcelain crab and the king crab, which with a name like that you'd expect to be a true fucking crab, but it's not. We refer to this group, the in-between circle, as the false crabs. Set. With headlines like animals keep evolving into crabs and scientists don't know why, and labels like true and false crabs, it seems like a few misunderstandings have been created about what carcinization actually is, specifically when it happens and who it happens to. Scientists aren't just walking into their lobster lab one day and finding crabs everywhere. We are not witnessing any elongated crustacean we saw at the beach last year pop up as a rotund creature the next. That would be fucked up, wouldn't it? This phenomenon is being witnessed on a scale of millions of years. As scientists have noticed that based on how these groups are related to each other, one group of crustaceans evolved a flat and rotund body plan during the early Jurassic, and other groups of crustaceans evolved in a way that looks almost completely identical to that later on. Unfortunately, or unfortunately, depending on your opinion, like I said before, to undergo carcinization, you must be a crustacean. But even more specifically, you have to be a decapod crustacean. So what is a decapod? The decapods are another taxonomic group that includes crabs, lobsters, shrimp, crayfish, etc.
Okay, all right, perfect. So insects can do it. The insects that are crustaceans can't do it. You have to be a decapod type of crustacean.
Means 10 legs. Deca, 10. Pod, legs. And this group has been around since at least the Devonian period, about 400 million years ago. One of the first decapods that we know of was alive during this time, called Paleopalaemon. And they, along with earlier decapods, had a body plan like that of a lobster, an elongated form. And over the next, say, 200 million years, the ancestors to the Brachyurans, the true crabs, adapted to a series of environmental conditions that led them to be carcinized, and the ancestors to the false crabs followed their lead. Here's what's interesting and makes this a little bit easier. Most of the false crabs are in the same group, the sister group to the Brachyurans. Their sister group is called Anamura. Brachyura,
She is dropping the information way too hard. I can't pick it up as fast as she's dropping it down. And again, I want to remind you, I want to emphasize this. This is normal speed. This is just regular speed, man.
Anamura. I'm gonna guess it's Anamura. Brachyura and Anamura are sister groups to each other, which means that they're most closely related to each other within the decapod group. Let's pretend this is scientifically accurate. I'm never gonna write on it. Bear with me, I'm left-handed. This is not for accuracy, this is just an example. Do you see how these two are most closely related to each other within this entire decapod group? That is what a sister group is. They got their own little thing going on. These two groups share a common ancestor that at some point split, with the Brachyuran lineage going crab and the Anamuran lineage going kind of fucking shit digging all over the place. I'm not gonna say that way. They had a diversity of body form, like squat lobsters and hermit crabs, and some of them were really just fucking with what the Brachyurans had going on and followed their lead, and got carcinized. Some examples, of course, are the king crab, who is thought to have evolved from a hermit crab ancestor, and the porcelain crab, thought to have evolved from some kind of squat lobster, and the hairy stone crab and other members of Anamura that went through carcinization separately and independently of each other. Okay, so why did this happen? Since unfortunately they didn't actually look at true crabs and decide their fate. How did this happen? Well, since it happened to so many different kinds of Anamurans independently, there must have been tons of different environmental stressors that all led to the same body form, the same adaptation. And to start thinking about some of those possible reasons, we have to look at some of the major adaptations that took place by looking at the anatomy of a decapod. Decapod kind of sounds like tech deck. Now all I want is a picture of a decapod on a tech deck. Tech deck decapod. To keep it simple, I'm going to go over two of the major adaptations. So, in the ancestral body plan,
she's like a TikTok YouTuber, if that's a thing. But I think I'm following the logic. So there was, out of all the crabs in the family of crabs in biology, there was just two families of crabs that were extremely close to each other, related to each other. One of them evolved really early on in the Jurassic, hundreds of millions of years ago, to become what we call true crabs, like the body, the form, right? But then there was the other group, the family very closely related to that, that decided to go in all sorts of ways and diversify their look, right? But then also a chunk of that group decided, actually, you know what, let's look at our cousins and design ourselves like them. So they went under customization as well. So that's why we get the idea of every everything that barely resembles a crab seems to be trying to become an actual true crab. It's not that all animals are trying to become crabs. It's just animals are already closely related to crabs and probably live under the same similar experience or environmental conditions or whatever. Like perhaps like a shrimp and a crab, if they live near each other enough for like millions of years, the shrimp will be like, man, the crabs are really doing good. Let me morph myself, evolve myself to look like a crab. So I think that's what's happening. Crazy. So
Like
that makes sense. Like, is the crab the perfect form body to deal with like that type of situation, that ocean floor situation or beach situation or stuff like that?
lobsters and crayfish still have today. They have a sheet of exoskeleton that covers their head and thorax. I guess you can kind of think of a thorax as a chest. That sheet of exoskeleton is called the carapace. And then they have the abdomen behind that. The abdomen is long and the carapace is long as well, kind of like cylindrical. And in crabs, their whole thorax area or their sternum stretched out horizontally, creating a more flat, square-shaped carapace. And then the abdomen became reduced and folded underneath, as you can see. Okay, so that's what happened. But why? And why so many times under different conditions? Because hermit crabs seem to have done it too. If you want to think about this with me and come up with your own ideas, pause the video, sit with it for a little bit, and then come back and then we'll talk about it. If you don't want to, you don't have to. I can't make you do anything, but I would really like it if you would. Okay,
Yeah,
so I think the easiest place to start would be the folding of the abdomen underneath their body. That is clearly a much safer place to keep part of your body. Reduces the chance of predators snatching it up, so all your important shit is compact, tucked into a little briefcase. So it's easy to see why that became more favorable over millions of years, multiple times. And then with the ancestor to king crabs, the hermit crab ancestor, a shell was protecting the abdomen. Here's a picture of a hermit crab without a shell. And maybe something happened where those king crab ancestors found themselves in an environment that didn't have an abundance of shells lying around that they could move into. And so they were exposed and over millions of years adapted to protect their abdomens themselves, like an independent bitch. Some scientists have also
So that makes sense. Like a hermit crab has like a shrimp type body when they have the organs and stuff at the back, but they protect it with shells. But if they're the king crab evolved from them, then those crabs must have been in a situation where there weren't enough shells, they were exposed. So it was best to just kind of bring all that in, expand the chest, get arms, crab.
suggested that the folding of the abdomen could have been due to problems with movement. In hermit crabs with the heavy shell, and then with the lobster shape, the abdomen is muscular and heavy and weighs you down. So being that square, folded up, flat, little guy, lets you be more agile and escape danger more easily. Regardless of how it happened, it's incredible that it evolved at least 5 different times, from different starting points to create essentially the same exact creature. An absolutely classic case of convergent evolution. But there's something that Big Crab doesn't want you to know. Decarcinization is a thing too. And in 2021, a team of scientists found that decarcinization happened at least 7 different times, including in the true crab lineage, the Brachyurans. I will show you 2 of them. The frog crab.
What the fuck is that?
Unusual to say the least. They clearly have a longer carapace than the crab form. Their abdomen is sticking out. And my favorite extinct crab, alive 95 million years ago, called Callichimera perplexa. They were quite perplexa in a few different ways. They had big eyes with no sockets, mouth parts that looked like legs, and bent claws. And also had a more elongated carapace, unlike their Brachyuran brothers. And their abdomen was poking out too. These both serve as a perfect example that even though we joke about crab being the final form, that is not actually the case. Like any discussion of the evolutionary history of any group, what exists today is in transition, meaning even though we exist on a scale of time where everything feels set in stone because our years feel relatively long, every population is still responding to changes in their environment and evolving on scales that are just too small for us to observe in most cases. We just so happen to live in this specific moment with billions of years behind us and billions more to come, where multiple lineages have the crab form. And what happens in the billions of years to come can only be left to our imagination.
Yeah, no, that was a good video. Actually, that really was an informative video. It was very TikToky and super fast, but if you take enough pauses and actually listen, think about it, it makes sense. Like it can be. It's really depending on the environmental situation. It might be more advantageous to become a crab form, and sometimes it might be more advantageous to uh, evolve a different form. I guess I wouldn't know what would be the advantage of being like a frog crab or the other extinct crabs you talked about. But if there was some kind of benefit to it, then it makes sense why there's also decarcinization. But yeah, that was a good vid, very informative. Thanks to Lindsay, Nicole, for me. Thank you for tuning in. Hope you enjoyed it. You enjoyed it. Leave your thoughts in the comments, and I'll see you on the next one. Peace out.